গুড মর্নিং স্যার, আপনি চাইলে আরেকটু পরেও জয়েন করতে পারেন।
হ্যালো, জয়িতা শুনতে পাচ্ছ?
হ্যাঁ, আমাদের স্পিকারও জয়েন করে গেছে।
আচ্ছা আচ্ছা, গুড মর্নিং স্যার। প্রফেসর মুখোপাধ্যায়, গুড মর্নিং।
গুড মর্নিং।
হ্যাঁ, আমি এখন, আমার নাম উপেন্দ্রনাথ নন্দী। আমি বর্তমানে ফিজিক্স ডিপার্টমেন্টের হেড হিসেবে আছি। আপনাকে অভিনন্দন। আমাদের এখনো শুরু আগে জয়েন করে আপনি দেখে নিয়েছেন সব ঠিকঠাক? হ্যালো,
হ্যাঁ
আপনি সব দেখে নিয়েছেন সব ঠিকঠাক তো?
হ্যাঁ, ঠিকঠাক বলতে যতক্ষণ পাওয়ার আছে ততক্ষণ ঠিকঠাক। লোডশেডিং হলে মিনিট 5 সময় লাগবে আমার ফিরে আসতে।
আচ্ছা আচ্ছা, না অ্যাকচুয়ালি ওই নরেন্দ্রপুরে আমার অনেকেই পরিচিত আছে। ওই প্রশান্ত আমার ব্যাচমেট কেমিস্ট্রির, পুলক 2 বছরের জুনিয়র।
আচ্ছা
হ্যাঁ হ্যাঁ, ওই একসঙ্গে বেলঘরিয়া রামকৃষ্ণ মিশনে আমরা থাকতাম হোস্টেল। প্রশান্ত তো ভালো কাজ টাজ করে রিসার্চের।
অবশ্যই।
হুম হুম, যাক খুব ভালো হয়েছে এটা শুরু হোক। ও প্রিন্সিপাল ম্যাম জয়েন করে গেছেন।
গুড মর্নিং, গুড মর্নিং।
হ্যাঁ, গুড মর্নিং ম্যাডাম, গুড মর্নিং।
একটু পরে আবার একটু পরে আসছি, সময় আছে তো?
হ্যাঁ, জয়িতা যেরকম বলবে আজকে। জয়িতা হচ্ছে
10:30 টাইম।
হ্যাঁ,
একটু পরে আসছি তাহলে।
হ্যাঁ ম্যাম, হ্যাঁ ম্যাম। বাহ, কতজন হয়েছে? 45। জয়িতা, আমাদের জয়দীপকে দেখলাম, সুশোভন টুশোভন এরা সব ঢুকে গেছে।
সুশোভন আছে স্যার, অনেকক্ষণ থেকেই আছে।
আচ্ছা, বাস বুঝতে পারছি না। আর যে জয়দীপকে দেখলাম, আর হচ্ছে ওই আমাদের রবিদা ওরা এখন আসেনি বোধ হয়, সদল্লা
না মনে হয়
না। আচ্ছা,
না, এসছেন, সদদলবাবু আছেন।
এসছেন, আচ্ছা আচ্ছা।
এই আমি আছি।
আচ্ছা আচ্ছা, ঠিক ঠিক ঠিক। আর তো 10টা 14 হয়েছে। এখন ধরো আমরা 10:30টায় শুরু করলে 15 মিনিট স্যার ওইভাবে থাকবেন। একটু কেউ কথা টথা বলো স্যারের সঙ্গে। আমি নালে এমনি তো এভরিথিং রেডি, ধরো আমাদের ওয়েল সেট, জাস্ট জয়িতা শুরু করলেই হয়ে গেল। 15 মিনিট এইভাবে নীরবে না থেকে একটুখানি স্যারের সঙ্গে একটু কথা বলো আর কি। সহদল্লা, তুমি স্যারের সঙ্গে একটু কথা বলো পরিচিতি ইয়ে করে।
এই শুভা এসছে কি?
শুভাকে আমি তো দেখিনি।
না, নেই নেই,
শুভা নেই না? সায়ন বণিককে দেখছি, সায়ন্তন, শুভায়ু তো সবগুলোতেই থাকে। বাহ, খুব সুন্দর। এটা বাইরের। তৌলিক ত্রম্বক, এখনো টাইম আছে তো, তখন ফটাফট জয়েন করবে এই 10টা 25 থেকে 30 বা 28 থেকে 30-এর মধ্যে। আমি স্যারকে দু একটা কথা বলি চুপচাপ না থেকে। সেটা হলো স্যার, এই লেকচারটা আমাদের অর্গানাইজ করে আসছি, আপনি দেখেছেন বোধহয়, এটা 9th প্রফেসর জেসি ভট্টাচার্য মেমোরিয়াল লেকচার। তখন হয়তো 1 মিনিটে সব বলার সুযোগ পাবো না, জাস্ট একটু দু একটা কথা আপনার সঙ্গে একটু শেয়ার করি। সেটা হলো যে উনি আমাদের ফিজিক্স ডিপার্টমেন্টের এক্স স্টুডেন্ট ছিলেন, খুব রিনাউন্ড, একটা গ্রেট এক্সপেরিমেন্টালিস্ট ইন অ্যাস্ট্রোফিজিক্স। ইন্ডিয়ান ইনস্টিটিউট অফ অ্যাস্ট্রোফিজিক্স ব্যাঙ্গালোর যেটা রয়েছে, সেখানকার ডিরেক্টরও হয়েছিলেন, এবং ইন্টারন্যাশনাল অ্যাস্ট্রোনমিক্যাল ইউনিয়ন তার ভাইস প্রেসিডেন্ট ছিলেন, প্রেসিডেন্ট হয়েছিলেন, ইন্ডিয়ান একাডেমি অফ সায়েন্সের মেম্বার ছিলেন, মানে খুব রিনাউন্ড। যখন আমরা একটু পড়ে ওনার বায়োডাটা থেকে যা বুঝেছি বা জেনেছি, আমরা কখনোই দেখিনি ওনাকে, যদিও ওনার শরীর গেছে 2012-তে 4th জুন ওনার শরীর গেছে। তখন আমাদের ডিপার্টমেন্টে একজন ছিলেন, আপনি নাম হয়তো শুনে থাকবেন, ডক্টর অরূপ রায়, আমাদের পদার্থবিদ্যা বিভাগের অনেক মানে কর্মকাণ্ডের শরিক, এবং অনেক কিছু উনি নিজস্ব চিন্তা ভাবনা দিয়ে করে গেছেন, সেটা আমাদের কাছে এখন আমরা জাস্ট ফলো করি সেগুলো অনেককেই। তা উনি তখন ওনার নামে একটা ওই 2012-তে প্রফেসর ভট্টাচার্য শরীর যাওয়ার পরে উনি একটা ওনার নামে একটা প্রাইজ চালু করেন, এই মেমোরিয়াল লেকচার চালু করেন। তখন থেকে আমরা এটাকে পড়ে আসছি, এটা 9 নম্বর। এটা এমন একটা সাবজেক্ট, উনি বলে গেছিলেন যে ফিজিক্স হতে হবে তার মানে নেই, বিয়ন্ড ফিজিক্স হলেও চলবে, কিন্তু ফিজিক্সের বাইরেও। আমরা যেমন একটা মিউজিয়ামের একজনকে এনে করেছিলাম এরকম লেকচার, একজন আই সার্জেন এসেছিলেন, একজন ফিল্মের একজন লোক এসেছিলেন, বিভিন্ন মানে টাইপের একটা দিক আমরা স্টুডেন্টদের সামনে তুলে ধরতে পারি এই লেকচারটার থ্রু দিয়ে। তা আজকেও একটা আমরা নতুন, সত্যি এর আগে এরকম অঙ্কের উপরে আমরা মনে হয় না, আমার মনে হয় না অঙ্কের উপরে পার্টিকুলারলি কোনো সেমিনার বোধহয় করেছি, তাই তো?
না, আমাদের হয়নি, এটাই প্রথম।
হ্যাঁ, এটাই প্রথম। তা সেই সেন্সে, এবং গ্রেট ম্যাথামেটিশিয়ান, বলার তো কিছু না, আমরা শুধু নামই শুনেছি। আজকে তার কিছুটা ভেতরে ঢোকার চেষ্টা করব আপনার সাহায্যে, এটা আমরা খুব মুখী আছি, এটার জন্য খুব ভালো হবে আমাদের। সেই তখন থেকে এই লেকচারটা চলে আসছে। এটা একটা ফিজিক্স অ্যালামনাই অ্যাসোসিয়েশন আমাদের একটা আছে, বহুদিন থেকে সেটা অ্যাক্টিভ। তার একটা ইম্পর্টেন্ট অ্যাক্টিভিটিজের মধ্যে একটা, অনেকগুলো অ্যাক্টিভিটিস রয়েছে, তার মধ্যে এটা একটা। সেটাকে আমরা প্রত্যেকটা বছর এইভাবে অর্গানাইজ করে থাকি। এই হচ্ছে একটু ব্যাকগ্রাউন্ডটা আপনাকে একটু বলে রাখলাম। তখন চুপচাপ বসে না থেকে এখন 10টা 20 বাজে প্রায়, এই আর একটা। আর নরেন্দ্রপুরে আমি গেছি, পরীক্ষা নিতে গেছি। দেবু আছে আমাদের জুনিয়র ভাই, হ্যাঁ, ওনার আমাদের জয়দীপ মিত্র বলে একজন আছে, আমাদের চেয়ে একটু জুনিয়র, ও তো রেগুলার বেসিসে ওখানে যায় নন্দপুরে পরীক্ষা, কোশ্চেন সেট করতে এরকম যায়। আর দেবনারায়ণ জানা বোধহয় আপনাদের ওই ফিজিক্স এমএসসি তে পড়ায় ক্যালকাটা ইউনিভার্সিটি, প্রফেসর জানা, ও আমার ক্লাসমেট, খুব ক্লোজ। ওর সঙ্গে আমার বেশ কিছু কাজও আছে, রিসার্চের বেশ কিছু কাজ আছে, 2-3টে বইও লিখেছি একসঙ্গে আমরা, এই আর কি। যাই হোক, একটু
আসলে এই রকম ধরনের প্ল্যাটফর্মের সমস্যা হচ্ছে, দেখুন, স্পিকার হিসেবে যে কাউকে তো দেখা যায় না,
ঠিক,
যারা শুনছেন তারা আদৌ কানেক্ট করতে পারছি কিনা তাদের সেটা বোঝার উপায় নেই, নিজেকে কিরকম একটা ফাঁকা মাঠে তরোয়াল চালাচ্ছি টাইপের মনে হয়।
ঠিক।
আর আরেকটা সমস্যা হচ্ছে যে অডিয়েন্স কম্পোজিশনের ওপর কোনো নিয়ন্ত্রণ থাকে না।
ঠিক।
যেমন আপনার কলেজে যদি আপনার ডিপার্টমেন্টে ব্যাপারটা হতো, তাহলে আমি যেমন ধরে নিতাম যে ওখানে ফিজিক্সের ছাত্ররা থাকবে, অতএব অঙ্কের অমুক লেভেল পর্যন্ত আমি যেতে পারি। এই ধরনের প্রোগ্রামে যেটা মুশকিল হয়ে যাচ্ছে যে এখানে তো যখনই জিনিসটা পাবলিক হয়ে যাচ্ছে তখনই এনিবডি ইন্টারেস্টেড ক্যান জয়েন, ফলে কম্পিটিশন অফ দ্য অডিয়েন্সটা ভীষণভাবে হেটেরোজিনিয়াস হয়ে যায়।
একদম একদম।
ফলে টেকনিক্যাল জিনিস কতদূর বলা যাবে, কতদূর বললে লোকে নিতে পারবে, কোথায় তারা বোর্ড হয়ে যাবে বা কানেক্ট করতে পারবে না, এটা গেস করা ভীষণ ডিফিকাল্ট হয়ে যায়।
আচ্ছা, ভাইস প্রিন্সিপাল স্যার জয়েন করেছেন। স্যার গুড মর্নিং। অ্যাকচুয়ালি টাইম আছে বলে আমরা স্পিকারের সঙ্গে একটু গল্প করছি।
হ্যাঁ শিওর। গুড মর্নিং প্রফেসর মুখোপাধ্যায়।
গুড মর্নিং।
হ্যাঁ স্যার বলুন প্রফেসর মুখোপাধ্যায়, যেটা বলছিলেন প্লিজ প্লিজ কন্টিনিউ।
হ্যাঁ ওই বলছিলাম ওইটাই আর কি, যে নিউ নর্মালে প্রবলেম যেটা হচ্ছে স্পিকারের, সেটা যে সামনে অডিয়েন্স থাকলে যেটা সুবিধা হয়, নিজেকে মোটিভেট করা যায় লেকচার দিতে দিতে, যে আমি যা বলছি সেটা পৌঁছচ্ছে কিনা সবার পর্যন্ত, সেই বুঝে প্রত্যেক মুহূর্তে নিজের বক্তব্যকে টিউন করা যায়। আরো বেশি বলবো না, এইখানে থেমে যাব, অন্য কোথাও চলে যাব, এগুলো প্রত্যেক মুহূর্তে জাজ করা যায় সামনে বসে থাকা অডিয়েন্সের চোখ মুখ বা বডি ল্যাঙ্গুয়েজ দেখে। সেইটা এই মিডিয়ামে কমপ্লিটলি অনুপস্থিত।
ঠিক ঠিক। ম্যাম জয়েন করেছেন।
আরবিট্রারিলি বলে যেতে হয় যে আমি যেটা বলবো ভেবেছি বললাম, এইবার যিনি বুঝলেন বুঝলেন, যার ভালো লাগলো লাগলো, যিনি শুনলেন না কিছুই করার থাকে না।
আচ্ছা ম্যাম, আমরা টাইম আছে বলে স্পিকারের সঙ্গে একটু গল্প করছিলাম, মানে এখনো শুরু হয়নি। উইথ ইউর কাইন্ড পারমিশন।
শুনতে ভালো লাগছে।
হ্যাঁ হ্যাঁ হ্যাঁ, এখনো ধরুন 10:22 হয়েছে।
হ্যাঁ হ্যাঁ, আর একটু সময় আছে।
একটু সময় আছে, আমরা এই জন্য একটু গল্প করছিলাম।
আচ্ছা একটা জিনিস আমাকে বলবেন, যারা শুনছেন, মানে আমি এই যে আমার মাথার উপরের ফ্যানটা চালালাম, এতে কি আমার কথা শুনতে আপনাদের অসুবিধা হচ্ছে? মানে
কথা পরিষ্কার শোনা যাচ্ছে।
শোনা যাচ্ছে তো?
হ্যাঁ হ্যাঁ,
থ্যাংক ইউ।
অ্যাকচুয়ালি স্যার মুখোপাধ্যায় স্যারকে বলি যে আমাদের কিছুদিন আগে আমরা একটা সেমিনার করেছিলাম, টাটা ইনস্টিটিউট অফ ফান্ডামেন্টাল রিসার্চের প্রফেসর কালবরণ মাইতি বলেছিলেন। সেখানেও অনেক, প্রায় 700 কাছাকাছি অডিয়েন্স ছিল, রেজিস্টার্ড পার্টিসিপেন্ট। খুব ভালো হয়েছে। তবে একই বক্তব্য, ওই সামনাসামনি আর দূর থেকে এটা নিয়ে উনিও একটা বক্তব্য বলেছিলেন, পয়েন্ট। অ্যাকচুয়ালি স্যার আমাদের কলেজে এখন বিভিন্ন ডিপার্টমেন্ট বিভিন্ন সাবজেক্টের উপরে এই ওয়েবিনার করছে এবং খুব ভালো ভালো বক্তা আসছেন। হ্যাঁ, এই হিস্ট্রির একটা হবে কদিন পরে। হ্যাঁ, হয়ে গেছে, অনেকগুলো হয়ে গেছে। প্রথম বোধহয় মাইক্রোবায়োলজি শুরু করেছিল ম্যাম, আমি ঠিক বলছি বোধহয়?
হ্যাঁ, মাইক্রোবায়োলজি দিয়ে শুরু হয়।
হ্যাঁ,
আমাদের কলেজে, ওই সব কলেজই এখন এই নিউ নর্মাল সিচুয়েশনে এই একটাই মিডিয়াম, তো আমাদের কলেজেও চলছে। অঙ্ক ডিপার্টমেন্টই আমাদের 3টে লেকচারের মধ্যে হয়ে গেল গত এক মাসে, আবার এই মাসের 28 তারিখে একটা আছে। আমি নিজে গত এক মাসে, এটা আমার 6 নম্বর লেকচার। বিভিন্ন জায়গায় বিভিন্ন রকম।
এখন তো উইকডেজ আর রবিবার সব এক।
হ্যাঁ,
আলাদা ওয়ার্কিং ডে বলে কিছু নেই, সব রোজই ওয়ার্কিং ডে। সন্ধ্যাবেলাও কাজ হয়
না, তার মধ্যে
ক্লাস নিচ্ছি সন্ধ্যাবেলা, আমি তো ছেলেদের ক্লাস নিচ্ছি সন্ধ্যে বিকেলে 4টে থেকে 7টা।
তার মধ্যে আমরা আবার লকডাউনের দিনগুলো বেশি করে বাঁচার চেষ্টা করছি, কারণ লকডাউনের দিনগুলোতে তো আরো কোয়াইট থাকে, কারণ সবই বন্ধ, মানুষের বেরোনোরও থাকে না।
না আসলে প্রথমে 3 মাস ছুটি নিতে নিতে এখন তিতি বিরক্ত হয়ে গেছে সবাই, যার ছুটি চাই।
মানে আমরা যাদের কলেজে কাজ দিয়েছি টিচারদের, তারা অনেকে এখন আমাকে এবং প্রিন্সিপালকে বিশেষ করে বলছেন যে বাঁচালেন আমাদের। ইভেন নন টিচিং স্টাফেরাও বলছেন যে বাঁচালেন, কলেজে আসতে পেরে আমরা পড়তে যাচ্ছি। মানে পাগল হয়ে গিয়েছি কলেজে থেকে থেকে, বাড়িতে থেকে থেকে।
ফিজিক্যালি যাওয়াটা তো এখনো রিস্কি। এই জিনিস ভারতে কতদিন থাকবে? আমার তো মনে হচ্ছে না জানুয়ারি মাসের আগে কোনো রকম ইমপ্রুভমেন্টের কিছু আসবে।
তাই সামনের বছরে যদি আবার একটা
ম্যাথমেটিক্যালি যেভাবে কাজ করে উঠছে, তার মধ্যে আরেকটা খুব অ্যালার্মিং লাগছে টেলিভিশনে শুনে শুনে, যে দুর্গাপুজো কমিটিরা সবাই হাত গুটিয়ে নেমে পড়ছে যে দুর্গাপুজো হবেই, এবারে হবেই এর খেলায় কি দাঁড়াবে ব্যাপারটা। লোকজনও যদি রাস্তায় নেমে পড়ে যে দেখবোই বলে, তখন যে আবার মানে ধরুন একটু কমের দিকে হয়তো অক্টোবরে আসবে, তখন যদি সবাই রাস্তায় নেমে পড়েন তখন তো আবার একটা ভয়ঙ্কর দিক
ছড়াবে, খুবই ছড়াবে।
এই বছরটা সেন্সিবলি মানুষের উদ্যোগে ঘট পুজো করে বা কিছু করে শাস্ত্র মতে যা বিধান আছে, যে একটা বছর যদি এরকম অবস্থা হয়, ডেফিনেটলি শাস্ত্রে তার ব্যবস্থা আছে যে কিভাবে কন্টিনিউ করে যেতে হবে পুজোটা কোনো রকম আড়ম্বর ছাড়া, সেরকম কিছু ভাবা উচিত।
বড় বড় পুজো উদ্যোক্তারা অলরেডি বলছেন, মানে সেদিন দেখলাম যে একডালিয়া এভারগ্রিনের পক্ষ থেকে বলা হচ্ছে, যিনি বলবার তিনি বলছেন যে আমরা তো সমস্ত ব্যবস্থা রেখেই পুজোটা করব।
এই সমস্ত ব্যবস্থার কথাটা তো মানে নেই, দর্শকদের জন্য তো আর সমস্ত ব্যবস্থা হবে না।
এই কোট আনকোট সমস্ত ব্যবস্থাটা তো আমরা 6 মাস ধরে দেখতে পাচ্ছি।
তো সব রাজনৈতিক দলই তো সমস্ত ব্যবস্থা রেখে তাদের আন্দোলন, ভয়ঙ্কর সব আন্দোলন করেন, তো তারা প্রত্যেকটি রাজনৈতিক দলই সে তো করে চলেছেন, ব্যবস্থা খেলা তো দেখতে পাচ্ছি। মুশকিল হচ্ছে সাধারণ লোক যদি মনে করে যে চল একটু অমুকটা দেখে আসি, সেখানে কি হচ্ছে, তাহলেই তো বিপদ। লাখ লাখ লোক রাস্তায় নেমে পড়লে।
আর এটা তো এত সেন্সিটিভ একটা ইস্যু যে তো পুলিশ প্রশাসন নিয়ে কিছু করা যাবে না, চুপ করে থাকতে হবে।
নিজেদের সেন্সিবিলিটি নেই, দেখা যাচ্ছে বিশেষ করে বাঙালি জাতি সেন্সিবিলিটি, রেসপন্সিবিলিটি সেন্স খুব ভেরি পুয়ার। আমি তো আমার অঞ্চলে এখনো দেখি লোক মাস্ক ছাড়া ঘুরে বেড়াচ্ছে।
হ্যাঁ, মাস্ক ছাড়া ঘুরে বেড়াচ্ছে,
এটা
কিন্তু অনেক
সারা কলকাতাতে।
এবং যারা করছে তাদের একটা ডেফিনিট পার্সেন্টেজ লোক ওটাকে গয়নার মতন চিবুকে ঝুলিয়ে রাখছে।
ওটার একটা নাম দিয়েছে থুতনি কুমার বলে, থুতনির কাছে ঝোলে, তাই থুতনি কুমার।
কুমারী সবই আছে। এবং এদের অ্যারোগেন্ট এবং অবস্টিনেট, যে এদেরকে রাস্তায় দেখে যদি এমনি বলি যে দেখুন করেছেন যখন, এটা একটু নাক মুখ ঢাকা দিয়ে দিন না, আর যা তারা উত্তর দিচ্ছে তাদের মানে কুমার তুমি এবং নির্বুদ্ধিতা দেখে মানে সত্যি। সবচেয়ে খারাপ দিক হচ্ছে যে একা তার নিজের ভুলে সে নিজে ডুবতো, সেটা একরকম ছিল, কিন্তু সবাইকে নিয়ে ডুবছে না।
এটা তো একটা মানে গোষ্ঠীগত ব্যাপার, তো একজন ভুল করলে গোটা গোষ্ঠী
বলবে।
সময় হয়ে এসেছে বোধহয়।
হ্যাঁ জয়িতা,
হ্যাঁ এবার আমরা শুরু করতে পারি। হ্যাঁ
হ্যাঁ
Good morning. Today we have assembled virtually to pay our homage to renowned astrophysicist Professor Jagadish Chandra Bhattacharya, who was an illustrious student of Physics Department of Scottish Church College. We are honored to have Dr. Parthasarathi Mukhopadhyay as the speaker of 9th Professor J.C. Bhattacharya Memorial Lecture. I request our principal, Dr. Orpita Mukherjee, to inaugurate the program with her address.
Thank you, Joyita. A very good morning to you all. Dr. Parthasarathi Mukhopadhyay, Associate Professor, Department of Mathematics, Ramkrishna Mission Residential College, Narendrapur. Dr. Supratim Dash, our Vice Principal. Dr. Upendranath Nondi, Head Department of Physics. Dear friends, colleagues, and my dear students, I welcome you all to this online platform for the 9th Professor J.C. Bhattacharya Memorial Lecture, organized by the former students of the Department of Physics. First, I would like to take this opportunity to thank Dr. Mukhopadhyay for agreeing to address our students today, despite his busy schedule. In the present world of online academic meets, Sundays are like any other day of the week. The webinar today is about, or rather it is on, Srinivasa Ramanujan, a mathematician of inexplicable originality. I am not adequately qualified to make any observation on Ramanujan's works, but I would like to take the liberty of commenting on certain remarkable aspects of his personality. His extraordinary love of mathematics, his determination and perseverance. When all of 15 years old, he had obtained a copy of George Shoebridge Carr's Synopsis of Elementary Results in Pure and Applied Mathematics, a collection of thousands of theorems, some with the briefest of proofs. This roused his interest in mathematics. Not only did he verify the results in Carr's book, but he went on to develop his own theorems and ideas. He was self-taught to a great extent. When only 16, he secured a scholarship to the University of Madras, but lost it the following year because he neglected all other studies in pursuit of mathematics. He was unemployed, and after struggling for a while, he obtained a clerical post with the Madras Port Trust. His genius slowly gained recognition after he published the first of his papers in the Journal of the Indian Mathematical Society. He overcame religious inhibitions to travel to England in 1914 to collaborate and work with the British mathematician Godfrey H. Hardy, with a special scholarship from the University of Madras and a grant from Trinity College, Cambridge. Ramanujan overcame the setbacks of day-to-day living, egged on by his determination and encouraged by his extraordinary ability to solve complex mathematical problems. He burst upon the mathematical scene with a series of brilliant discoveries. When he passed away at the young age of 32, he left behind many unpublished results that mathematicians continue to verify long after his death. Ramanujan's love of mathematics overrode all else in his life. It is certainly difficult to emulate such single-minded determination and dedication, but that is what genius is all about. I welcome you all once again to this webinar. I wish it a great success. Thank you.
Thank you, madam. I request our Vice Principal, Dr. Supratim Das, to say a few words.
A very good morning. Time is very short, so I would like to go straight to the point. It is a brief narrative of the binary of center and periphery. Srinivasa Ramanujan, born in 1887, was an exceptionally talented algorist, though he did not have the good fortune of a formal university training. He became a mathematician before anybody could think of training him. One may say that he was uneducated, if I may be permitted to use that word, compared to any mathematician in the world, because Ramanujan was a self-taught genius. His dramatic rise to world recognition and his very short career of formalized activity in some of the best universities of the world amount to a thrilling success story so far as the world of mathematics and the pride of India are concerned. Ramanujan began a correspondence with Professor G.H. Hardy, then Fellow of Trinity College, Cambridge. If I am not wrong, his first historic letter to Professor Hardy in January 1913 contained an attachment of 120 theorems, all originally discovered by him.
আপনি জয়েন করেননি?
So history was made.
হ্যাঁ, কারণ পরেই আপনার বলা, হ্যাঁ।
Hardy brought him to England in March 1914. In England, Ramanujan was not always well. He had a very ill health. He fell sick and wrote notebooks while at English nursing homes. We know the celebrated Italian thinker Antonio Gramsci's prison notebooks is a treasure house of theoretical Marxism that he wrote in Benito Mussolini's prison. Ramanujan's notebook is such a treasure house which contains about 600 fascinating results. I have heard, and if I am not wrong, more than 200 research papers have been published in the world as a result of Ramanujan's discoveries. Ramanujan went far beyond the mathematical knowledge and skill of his teachers. As the continuing study by later mathematicians of his notebooks has shown, he also moved well beyond the tradition of mathematics in Europe, of which he became aware in Cambridge. Let it be noted that at Cambridge, Ramanujan never lunched or dined in hall. He never went to feasts. He never went to the combination room. He did not go to wine after dinner. That kind of cordiality he never had with Hardy, Littlehood, or Neville, the Cambridge masters.
না আমাদের প্রোগ্রাম তো চলছে
Rather,
প্রিন্সিপালের
he
অ্যাড্রেস
had a
হয়ে গেছে
great
ভাইস
deal of
প্রিন্সিপাল
intellectual
বলছেন
cordiality and passionate interchange about mathematical problems with equals. I would like to give emphasis on the word equals. That is what Srinivasa Ramanujan received from his years at Cambridge. Cambridge was no doubt the center.
সুদেব ভট্টাচার্য বাবুকে বলা আছে
Ramanujan went from the periphery, that is
ঠিক
India.
আছে আপনি যখন পারবেন
Thanks to the potentialities of a genius, a sector of the periphery could now become a center. Thank you.
Thank you, sir. Now, I request Dr. Upendranath Nondi, the head of the Department of Physics, to say a few words. Sir, we can't hear.
Oh. Okay. Now you can hear? It's audible now?
Yes, it is okay now.
Okay now. So, respected Principal Ma'am, Dr. Urpita Mukherjee, respected Vice Principal Sir, Dr. Supratim Das, and today's speaker, Professor Parthasarathi Mukhopadhyay, our colleagues and the registered participants, above all, the former teachers of the department and the alumni. Today we are going to have the 9th Professor J.C. Bhattacharya Memorial Lecture. Already before starting of the meeting, I was discussing with the speaker something about this. Professor Mukhopadhyay was an ex-student of this department and is a renowned experimentalist in astrophysics. Actually, he devised some methods when during the sun flare, you know, the ionosphere gets ionized to a different degree. So how to measure that ionic state of the ionosphere during that particular situation, he devised a method. It's a very good one, very good one. And he was the director of Indian Institute of Astrophysics, Bangalore. He received several prizes, international figure. He was the vice president and also the president of International Astronomical Union. So it is our great pride to have him as the student of the Department of Physics. And he died in 2012, 4th June. During that time, in our department, we had Professor Dr. Arup Rai. He told that we should do something in the memory of this great personalities or great experimentalists in this particular field. Since then, we are organizing this as a joint event, joint program of the Department of Physics and Physics Alumni Association. And we are continuing this with the support of the college and the alumni. So thank you very much. Over to Dr. Joyita Chaudhary.
Dr. Amitav Dotto, President of Former Students Association, just informed me that he is unable to join due to network problem. So let's move on to the technical session. Dr. Mukhopadhyay, please start. I request to all participants, please turn off your camera and microphone. Don't write anything other than questions related to this lecture in the chat box. Please cooperate with us.
Thank you. A very warm welcome, very good morning to everybody. I find it a distinct honor and privilege to be invited to deliver this lecture in the memory of the illustrious Professor J.C. Bhattacharya. Today, I'll be talking on glimpses of some life story and work of a mathematical legend of our country, Srinivasa Ramanujan. So allow me to present my slides. I'll start with the presentation. Just give me a few.
প্রফেসর মুখোপাধ্যায় আপনার মাইক্রোফোনটা অন করুন প্লিজ সুইচ অন ইউর মাইক্রোফোন প্রফেসর মুখোপাধ্যায় yes
Yeah. Are my slides visible?
Yes, sir.
So allow me to begin. As you can see, today the talk is on glimpses of life and work of Srinivasa Ramanujan. Already something has been mentioned about his extraordinary life story. Let me see how far I can supplement to that. As you see, he was born on 22nd December 1887, and this year is his death centenary. He left us on 26th April 1920. Sometime before his death, when he was very seriously ill, he once told his wife, Janki Ammal, "My name will live for another 100 years." You can see how prophetic, how extraordinary this statement was. It is 100 years already, and we are still celebrating Ramanujan, not only in India, but all over the mathematical world. Everywhere, people who are aware of number theory, particularly analytic number theory, Ramanujan is still being read, explored, and rediscovered again and again in terms of his unusual results and the new interpretations. Ramanujan is considered as a self-taught genius of inexplicable originality. Self-taught in the sense that he never had an opportunity of formal mathematical training from university. And his originality, there is no doubt about his originality, his typically own way of doing mathematics. And the most important part is this inexplicable. This word is the most mysterious and rather unfortunate, I would say, that we are still not aware and possibly will never be aware of his ways of doing mathematics. It was so unusual because of the untrained mind. It is said that Ramanujan, in his short span of life, rediscovered about 150 years of mathematical works of the whole Europe by himself, all by himself for himself, without knowing that these things are already discovered, and then extended that for another 100 years' time. The way he did mathematics is completely unconventional. The most unfortunate part is he could never explain it to anybody. Rather, never had the opportunity of explaining in that way, if I can put it that way, because when Ramanujan came back from England, he was a celebrity by that time. He was a fellow of Royal Society by that time, and Madras University offered him a professor post, which he actually accepted by writing a letter telling that once I recover a little bit, I'll join. But that was not to be. As the most unfortunate part of the whole story, that had destiny granted him this scope, joining as a professor, as a research professor in Madras University, if he could have had some students under him, possibly then his way of doing mathematics, his way of thinking mathematically would have been known to us through his students. So that's a very unfortunate part of the whole Ramanujan story, that it remains inexplicable. Let me share with you, to begin with, such a story, a true fact actually, from the reminiscence of one of his friends in Cambridge, that will tell you his peculiar way of doing mathematics. This is, the time is sort of 1914 that I am talking about. Ramanujan is in Cambridge, befriended with some of the Indians, apart from doing mathematics with Hardy and Littlewood. Because one of his friends was this gentleman, P.C. Mahalanobis, Prashanta Chandra Mahalanobis, latter who became the father of Indian statistics. He is the founder of ISI, everybody knows him. He was a good friend of Ramanujan in Cambridge. He was in King's College and Ramanujan was in Trinity. Every Sunday they used to meet. Mahalanobis used to come to Wavell's Court, the house, the block where Ramanujan had his quarter, and they used to talk, discuss certain things. So this is in December 1914. Our story begins there. One fine such Sunday morning, Mahalanobis was sitting in the drawing room, going through the papers and magazines in front of him, and Ramanujan was in the kitchen, doing something for himself, as has already been told by one of our previous speakers, that he used to observe very strictly the Brahminic way of living. Even when he was in Cambridge, he used to cook for himself, and he was doing such thing. And Mahalanobis, a student of physics then, was going through a particular magazine. The magazine, its name was Strand, and there was a section, Perplexities, is a section on puzzles. And Mahalanobis found a puzzle there. It was related to some, there's a time of First World War. So this puzzle was related to a story that actually happened, that took place, very unfortunate barbaric act by German soldiers in Belgium, Louvain. They burned down a whole library and the whole community there. And this particular magazine, they chose to make a puzzle referring to that particular story. So cutting that long story short, The mathematical part of the puzzle was this, as you can see in front of you. I have boxed it by red. That's the puzzle. Imagine that you are on a street with house numbers marked through from 1 to n. And there is a house in between, x. The speciality of this house is, to the left of x, if you sum up the number of the houses, and to the right of x, if you sum up the number of the houses, then these two are equal. It is given that total number of houses on the street is more than 50, but less than 500. And the puzzle is to find out the number of houses, n, and the possible value of x with respect to this constraint. Now, Mahalanobis, being a physics student, a brilliant student, one of the brilliant students, he could actually calculate and find it out for himself, very likely this way. That suppose this is the house, if you can see my slide, this is the house number x, and if you just sum up 1 to x minus 1 to the left of it, this sum is equal to the sum of the integers, positive integers from x plus 1 to n. And that leads to a very simple equation, because summation of positive integers from 1 to x minus 1, as you can see, is x into x minus 1 by 2. And the right hand side being same, this is again x into x minus 1 by 2. And if you sum the number of the house x in particular with it, then the total sum should be equal to the sum of the first n positive integers, which is n into n plus 1 by 2. So if you simplify, that leads to a quadratic of x, and you can very easily see that this x is actually square root of n into n plus 1 by 2. Of course, Mahalanobis could see that, and with a little bit of trial and error, guessing the value of n so that either n is a perfect square, n by 2, or this n plus 1 by 2 is a perfect square, he could guess the solution. As you can see, one of the possible simple solution is x is equals to 6 and n is equal to 8, in the sense that if the house number is 6, then to the left of 6, 1 to 5, the sum is 15. And to the right of it, if the total number of house is 8, then to the right of it, the house number 7 and 8, that sum is also 15. So 6 and 8 is one possible pair of solution, but that is not a solution of the particular puzzle, because there was a restriction. The total number of house has to be more than 50, but less than 500. So with a little bit of more effort, with a little bit of more calculation, Mahalanobis could pin down the solution. It is x equals to 204, n is equal to 288. That is the solution to this particular puzzle. Now the story is this. After solving it mentally, maybe within a few minutes, like we did now, Mahalanobis thought of asking the question to Ramanujan, just to check how Ramanujan solved this, how much time he takes. So he just, told Ramanujan aloud that, Ramanujan, there is a problem for you. Can you solve it? So Ramanujan from the kitchen answered, yes, just short, go on. And Mahalanobis dictated the problem aloud. As soon as he finished telling the problem, Ramanujan told him, yes, okay, you just take down the solution I'm telling you. And Ramanujan told this solution. This is a continued fraction, as you can see here. And Mahalanobis was completely, surprised, taken aback. What this solution has to do? What is this continued fraction here? What is it doing here? So he asked Ramanujan, I just want to get you, what do you want to mean by this? And Ramanujan says, well, you see, the problem is very simple. If you have that restriction from 50 to 500, but what I have given you is a general solution of this problem. If there is no restriction on n can be any positive integer, however large, and you still have this similar problem that you want to find out the number x, so that to the left of x and to the right of x up to n, the sum of the numbers, sum of the integers are equal, then what are the all possible solution of this problem? That is given in this particular solution of mine. You see, this is Ramanujan. The continued fraction that came to his mind is this, and I don't have details, don't have time to get into mathematical details of it. These continued fractions, you can stop it at any point, getting the convergence. And the table here in the right hand side shows you that it gives you all possible solutions in the sense that you can see here 6 and 8. The first simple solution that I have already pointed out, that when total number of houses is 8, 6 will be the particular x, so that the condition is true. When total number of houses is 49, 35 will be the particular house number, and then this is the particular solution of the Strand magazine, the solution that Moholy-Nagy reached. And you see there are so many, and this is not the end of the road, my friends. This table can be continued ad infinitum. That is the way Ramanujan did mathematics. Now, once that is understood, Moholy-Nagy was completely puzzled. He asked that how on earth you could think, you could see that this is a solution in general. And Ramanujan, while answering, was equally surprised. He told, why? As soon as you were telling the particular problem, it immediately came to my mind that this answer should be a continued fraction. So I asked myself, what continued fraction? And the answer came to my mind. See, that was the problem with Ramanujan. Solutions used to come to his mind. He could never explain how. Such a strong intuition, such a peculiar, uncanny way of doing things, conjecturing again and again and again the right answer, without being able to explain how he could guess that right answer. But it has been proved later that all of his results, barring 4 or 5 with some typographical error, turned out to be true. Some 20 years after, some even 50 years after his death. Amazingly, some of these results required certain areas of mathematics to prove the result, such that those areas were never ever there at the time of Ramanujan. The areas actually were developed after the death of Ramanujan, after 10, 20, 30 years of Ramanujan's time. This is how Ramanujan used to do mathematics. This is the inexplicability of its genius, that he could never explain himself. You know, if you just see what Hardy said about him, one particular at particular point in his fantastic book, The Mathematician's Apology, is the mentor of Ramanujan, G.H. Hardy, has been already mentioned, the Sadlerian professor of pure mathematics at Cambridge University, sort of 10 years older than Ramanujan. And look at the union. Ramanujan, a devout Hindu, a pious Brahmin, orthodox. Everything he used to do, every now and then he used to name his Namagiri, one incarnation of Lakshmi. Ramanujan used to believe that this is due to Lord, due to Namagiri, that he could actually do this mathematics. And look here at this gentleman, G.H. Hardy, a declared atheist. And it was their union that made this wonder of mathematics in only those 5-6 years' time. See, once about Ramanujan, Hardy told in his book, The Mathematician's Apology, it was his insight into algebraic formulae, transformation of infinite series and so forth, that was most amazing. I have never met his equal, and I can compare him only with Euler or Jacobi. He was by far the greatest formalist of his time. One gift it has, which no one can deny, profound and invincible originality. He would probably have been a greater mathematician if he could have been caught and tamed a little in his youth. Remember, my friends, when Hardy met Ramanujan, Ramanujan was already 26 years. He's already formed his peculiar way of doing mathematics. And that's what Hardy is trying to point out. Probably could have been a greater mathematician if he could have been caught and tamed a little in his youth. But look at the next line, my friend. How prophetic utterance. On the other hand, he would have been less of a Ramanujan and more of a European professor, and the loss might have been greater than the gain. No doubt about it. That loss definitely would have been much greater than the gain. See, we are talking about his Cambridge time. If you just go back few years, say just by 7 years, At 1907, if you want to write Ramanujan's CV, this is the pathetic CV. If you want to look at it at 1907. In 1905, he failed in English composition at Government Arts College, Kumbakonam, where he entered with a scholarship, and the scholarship was lost. His name was struck out from the college list. Then he went back to his home, tried again to join another college in 1906, that was Bhattacharyya's College of Madras. And there, unfortunately, for 3-4 months, he could attend the classes. After that, he became ill, so seriously ill that he had to leave the study and go back to Kumbakonam, his hometown. And after the end of the year, at the end of 1907, as a private candidate, he appeared in the FA exam. FA is the first arts. Now that exam is almost equivalent to higher secondary today, the exam that you need to clear so that you can enter the BA degree in a university. So his aim was to join Madras Presidency College under Madras University for BA, but he could never do that. He again failed in 1907, and his name again got struck from the college roll. And then next 5 years, till February 1912, never got an admission to any university for pursuing bachelor's degree. All these 5 years he was doing mathematics all by himself, sitting in the Piyal Baranda of his house and doing mathematics over a slate, or sometimes in the nearby shrine of Sharangapani temple. He was doing relentlessly mathematics all by himself, and nobody could understand. This nobody does not mean his, neighbors only. This nobody includes the mathematics professors of that particular time of Madras, not only Indian professors, even European professors. Nobody could actually guess what was Ramanujan after. His results were so unusual, so peculiar, so unbelievable, that they used to think that this person is a nuts. He has got some bees in his bonnet. Some even thought that he was a kind of, intellectual cheat, deliberately writing the results in such a clumsy, difficult way that not even a mathematician can find out where it is wrong. That was his reputation at that point of time. And then on March 1912, after, patronage of some particular people that I'll come to later, he got a clerical job at Madras Port Trust. So that's Ramanujan in 1912. Now look at the change. It's like a fairy tale. That was 1912, and this is March 1916. Within 4 years, you see Ramanujan standing with some other fellows there in Trinity College, Cambridge. And he has received BA by research, not by writing any exam. Never after failure of Bhattacharyya's college, he was ready to write any exam anywhere. So this was BA from Trinity College, Cambridge by research. Research on what is known as a 62-page long paper on highly composite numbers that fetched him this BA degree. That's March 1916. And this is just 1.5 years more. 1917, 18th December, his name is being proposed to the Royal Society of London by these great names. I have just typed those names. If you can see this document, this is a Royal Society document I have here for you. Look at the signatories who are recommending Ramanujan for FRS, Fellow of Royal Society. Just try to imagine. If this is not fairy tale, then what else can be? The name includes Hardy, McMahon, Grace, Larmer, Hobson, Baker. I'll come to Hobson and Baker later. Littlewood. There's one interesting name, Bromwich. Also Whitaker, Forsyth, Whitehead. all FRS, all these people are fellow of Royal Society, and they are recommending Ramanujan's name to be FRS, and that was awarded in 2nd May 1918, the second ever Indian Fellow of Royal Society. The first one being one Gujarati gentleman, Ardasir something. He was a naval architect, not much known about him. And this particular name I'd like to draw your attention to. That's very interesting. This gentleman Bromwich, you know, just few years back when Ramanujan was doing mathematics all by himself, he by chance met one English gentleman who was once a student of mathematics, and he was sort of impressed by Ramanujan's work, but not being able to judge the actual value of what Ramanujan was telling. He has written some of the results to his professor in London University. The professor was M.G.M. Hill, and Hill within few months wrote back a letter, sort of patronizing letter, in a patronizing tone, that please don't dishearten this boy. This boy, Ramanujan, he is really interested in mathematics, but so unfortunate, this poor fellow, he doesn't understand what is convergence all about. He doesn't understand the series convergence. There's nothing wrong because these things are so new. These epsilons and deltas that even the great mathematicians, English mathematicians, sometime, you know, get into the pitfall of these epsilons and deltas. So my sincere advice is somehow manage a book of Bromwich on infinite series and ask him to read the book of Bromwich. So that was a suggestion, that was a prescription made to Ramanujan 5 years back. And now within 5 years, that gentleman is being referred for Fellow of Royal Society by that Bromwich himself. This is really unbelievable story of his life. So this is awarded in May 1918. And within 6 more months, October 1918 saw him as the first ever Indian Fellow of Trinity College. Fellow of Trinity. You see, one must mention that before becoming FRS, at least 6 months before becoming FRS, Hardy tried wholeheartedly, Hardy and Littlewood, to propose his name for the fellowship of Trinity College, but there were, you know, some of the professors who resisted. There's a very stiff resistance, and his name was turned down only because of the fact that he was an Indian, a black. How could an Indian be a fellow of Trinity College? But once Ramanujan became Fellow of Royal Society, then it was, you know, sort of compulsion for Trinity that a student of Trinity who is already FRS and Trinity is not elevating him as a Fellow of Trinity, that will be a shame for Trinity. So they had to accept. That's a story. That's a fact actually. So that is the unusual, meteoric rise of Ramanujan. And then, if you look at the time, this is October 1918, and within 1.5 years, he was due to leave us forever. Destiny only have granted him these 6 years, about 21 papers that he could write at that particular time in collaboration with Hardy. If you just go back to the beginning to see his original bloodline, you see his family, a Tamil Brahmin family, an Orthodox pious and very poor family. Of course, it's very strictly vegetarian. So Orthodox Tamil family, Brahmin family. And this is the Sharangapani temple I was referring to. This is the nearby street. It's called the Sharangapani Sannidhi Street, where Ramanujan was brought up, if not born. He was born in Erode, in the house of his maternal grandfathers. And you see, if you look at the family, its background, there is no genius in his family, neither before him nor after him. His parents were just ordinarily educated. His father was a clerk in a shari shop, and his mother, he was not conventionally literate, but of course she came from a family of Sanskrit scholars. So she knew about the Purana and the Mahabharata and Ramayana stories. She used to tell those things to Ramanujan. She had a tremendous impact on Ramanujan's life all through. And you see, unfortunately, in the young age, Ramanujan was the eldest son of the family, and within 7 years, 3 more younger brothers and 1 sister, they were born, and They died. After that, in 1898, a younger brother, Lakshmi Narasimhan, was born, and then further, 1904. So you see, they are much, much junior to Ramanujan. And they lived a long life. But if you look at them, look at their life story, they are just ordinary gentlemen. No shred of genius anywhere. Not mathematics, not anything else. They had ordinary, government jobs, and one of them became a sort of a postmaster. And in today's India, it is simply not known where this bloodline has gone. Whether there are still people in the same bloodline of Ramanujan, it's simply not known to us. So it is really a mystery that how suddenly such a genius like Ramanujan popped up in such a family. This is Ramanujan's mother, Komalatammal. This is the only picture that is available, only photograph. There's no photograph of Ramanujan's father is available. No photograph of Ramanujan himself in his early days. All photographs are after or just when he was going to, passport photograph. From then onwards, 5-6 photographs of Ramanujan is available, but none of his younger days. From the very presence of this lady, you see that she was a very, very dominant kind of personality. Her word was the last word in her family. Ramanujan's father was a very timid kind of person. And this lady has a great impact on Ramanujan's life. And this is the road, Sarangapani Sannidhi Street. And on this road, you have this house, the original house of Ramanujan. This is the Piyal veranda that I mentioned, where Ramanujan used to sit with a slate in his hand and relentlessly calculating mathematics on it. This house in 2003 had been taken care of by a private university, not by government. Private university's name is Shastra Shammuga Arts, Science and Technology Research Academy, and they have converted this into a kind of Ramanujan museum. Now if you go to Kumbhakonam, please visit this shrine of Ramanujan. There you will see this bust and some other letters and other documents, pictures, photographs of people related to Ramanujan this way or that way. These are some other busts of Ramanujan. The middle one is at Royal Society of London. And if you look at the early life of Ramanujan, we are very fortunate that Ramanujan, when he was only 2 years of age, he survived an attack of deadly smallpox. At that point of time, smallpox was a deadly disease. So we are very fortunate that Ramanujan survived from that attack. And then after shuffling from this school to that school at the beginning, finally, in Kumbhakonam, he was admitted to the Gangayan Primary School. And from what I have told you already regarding his miserable failure again and again in the colleges, if you tend to think that Ramanujan was a pathetic student throughout his life, then this is completely wrong. Let me rectify you and tell you that he was a brilliant student right from the beginning. He stood first in the whole district in his primary examination in the year 1897. And the exam was taken on English, Tamil, arithmetic, and geography. And with this scholarship, he entered the town high school. And in this town high school, at a very tender age, in one particular class, when his teacher was trying to teach him the class, the method of division, the teacher tried to explain by an example that if you divide a number by itself, it becomes 1. And he gave example like, see, if you have 10 bananas, and if you distribute them equally among 10 persons, then how many each person will get? 1. Immediately, young Ramanujan raised his hand and asked this question, Sir, if no fruit is distributed among no one, will still each get 1? So look at this person. Look at his original way of thinking right at that tender age. Ramanujan was asking, if 0 divided by 0 still equal to 1, because you told right now that any number divided by itself is 1. So if no fruit, that is 0 fruit, is divided among no one, that is 0 person, will still each get 1. That's how he used to think at that tender age. And every year he used to, have plenty of prizes, brilliant student he was every year. And when he passed out finally from the town high school in 1903, in a 1904, a special occasion, he received Ranganath Rao Prize from the school. And in that ceremony, the then headmaster, Mr. Iyer, told the audience, the guardian, that here is a boy who, you cannot judge him by giving 100 out of 100 in mathematics. That's not the right judgment for this boy, because it's technically impossible to give more marks than allotted. We cannot give more than 100 in an exam of 100 to this boy. That's his genius in mathematics. So that was the level of Ramanujan as a student in his early days. And then from town high school, he joined this Government College of Arts, Kumbhakonam, for pursuing FA, First Arts. And there, the whole life of Ramanujan changed. It's a complete paradigm shift. The principal madam has already pointed out about that. This was due to a particular book. And how Ramanujan got hold of that book? Actually, at that point of time, the Ramanujan's family, they were having two particular Brahmin boys as, guests, having again some sort of money, because that's a very poor family. It was very important for them to get some money out of this kind of adjustment. Those boys were staying with them, giving some money to the family, and they were in the college, Madras University College. Ramanujan used to pester those boys that you bring some mathematics books for me from your college library. So initially they brought Ramanujan the book of S.L. Loney, the trigonometry book. It is said that within 15-20 days, Ramanujan mastered the whole book, solved all the problems, and then started pestering them again. Now one of these boys thought about giving this particular book, what was a collection of 5,000 formulae. It was not a book actually. This book became famous in the history of mathematics just due to Ramanujan. There is nothing special of this book by G.S. Carr. This is the book, Synopsis of Elementary Results in Pure Mathematics. As you can see, it's a compendium of results. There's no proof in it. Barely stated 5,000 results in various branches of pure mathematics. And some historians of Ramanujan's life, they say that this is because of this book that Ramanujan's first interaction of higher mathematics happened with this particular book. Ramanujan thought that perhaps this is the style of presentation of higher mathematics, and that is why when he has written down his results, he never bothered to give any proof. He only stated the theorems, just like the style of this G.S. Carr. And you know what happened with this book? This book put Ramanujan in front of a kind of challenge. It's like a jungle of theorems. And each of these theorems was like, challenging Ramanujan. Come, prove me if you can. And that actually shifted the whole center of gravity of Ramanujan's life from everything else to mathematics, and only mathematics and nothing else. So what happened? Once a very good student, now he is trying to lag behind in every subject, even, my friends, even in the compulsory usual mathematics of his class, of his particular standard. He was not interested in that mathematics at all, because every now and then he was thinking about these new theorems that he see in this Carr's book. He was trying to prove them. And like this Ekalavya, he transcended his guru, Dronacharya, the Carr, and conjured again and again and again new theorems, new results that were not there in the book. And it is right then he started copying them down in one of the notebooks. This is the beginning of his famous notebook. The notebooks that were written and rewritten again and again and again. The first few notebooks are completely lost. Ramanujan later again and again refined them, reorganized them. But this is the beginning of his notebook, to try and write this result so that he may not forget this. And then what happened? As I have pointed out, his passionate sojourn of mathematics, and only mathematics, started taking its toll. And Ramanujan, who was once a very good student, all-round good student, he failed in the college final exam, except in mathematics, and lost his scholarship. And he could not bear this burden mentally. He was from a poor family. His scholarship was not just a question of status. The scholarship was absolutely necessary for continuation of study in that poor family. So after losing the scholarship, there was no way he could continue the study. And he was unable to bear this mental burden. He ran away from the home. And this you can see, my friends, in the right side of my screen. This is the insertion given on the missing boy by his father. This is Srinivasa Raghava Iyengar, his father. In September 2, they are giving this advertisement in Hindu that a Brahmin boy of Vaishnava Tengalai sect named Ramanujan of fair complexion, aged about 18 years, was still recently a student of Kumbhakonam. He left his home on some misunderstanding. For more than 1 month, Ramanujan was missing. Not much is known about how could he survive at that point of time. He was seen. Somebody says that he was seen at Rajamundry at some point of time in this 1 month, but how he could actually survive is not really known to us. But it just so happened that about a month later, he came back. And then in the next year, as I already have pointed out, he joined Pachayappa's college in Madras. From Kumbhakonam, he went to Madras, joined Pachayappa college, and within few days, with his brilliance, the mathematics teachers immediately understood that this is a special boy, and he was awarded a partial scholarship as well. But again, destiny thought it in a different manner. As I told you, within 3-4 months, he was ill, seriously ill, had to undergo a sort of minor surgery even, and he didn't have money for that. So somehow things became clumsy. And then it was a hydrocele operation. And thing went out of hand. And finally, he had to leave the college, leave his formal study, and he went back to his hometown, Kumbhakonam. And after 1 more year, because you have to show that 2-year study so that you can write that FA exam. So he had to wait for 1 more year. And then 1907, he wrote that exam and failed once again. I can show you his mark sheet of this FA exam. This was retrieved much later when Ramanujan was already a famous man. As you can see the date is University of Madras. It is retrieving the data in 1917. By that time, Ramanujan was a famous man, and the local British administration was, eager to find out a sort of CV of his whole life of this unusual person. And this is from the Madras University. As you can see the marks statement there. English, out of 270 is the pass mark, and Ramanujan scored 38. Sanskrit, 35 is the pass mark, he scored 34. And believe it or not, 150 in mathematics. Look here, my friends. Srinivasa Ramanujan's score of mathematics in FA exam is only 85 out of 150. So at that point of time, he was not even interested in doing this ordinary mathematics, because possibly while writing the exam, something clicked in his mind, some new theorem. And it was absolutely important that he must immediately leave the hall and go back and write it down somewhere before he forgets the result. So these ordinary, mundane work of routine mathematics and routine study was not for him anymore. He was not interested at all. And as you can see, physiology and history, simply 0. He submitted blank papers. And then, if that is your performance, it happened. It happened as it was due to. But once he became a complete failure in the formal education, these are his notebooks. They were bulging, one after another, 1, 2, and then the third one. They were getting filled up regularly with an exceptional brilliance, exceptional insight, unusual kind of mathematics. Those mathematics were never seen at that point of time by anybody. This is his own handwriting. And it's a matter of great pride for us that this TIFR has digitally reproduced these notebooks in these 2 volumes. Those 3 notebooks that I have shown you, they are now kept in Madras University, but these are digital reprographics, exact reproduction of Ramanujan's own handwriting by the color, by the way he has written everything. You can check them and see what exactly Ramanujan has written. And before I get into further stories of Ramanujan's life, I'll tell you something, I'll show you something from the notebook. That these are the first few pages of his first notebook as well as the second notebook. The second notebook is a rewritten version of the first one along with something new as well. And there in the first few pages, you see these kind of things. Right from page 1 to page 5, if you go through, these are called magic squares. This is by far the easiest thing that Ramanujan has written down in his notebook. And that's how I have chosen them to explain for the general mass. As I have pointed out already at the beginning, it's very difficult for us speakers nowadays to guess the composition of the audience, that how far mathematical we can go. So that's how I thought that this may be something interesting for all of you. Magic squares. And you see, I'll show you, I'll take this opportunity to show you something interesting from internet and like to show you how things are getting, distorted. How unnecessarily meat is being applied, is being tried to, adjoin with Ramanujan's name unnecessarily. We should understand what exactly he said. You see, these are kind of things that are called magic squares. The first one, as you can see here, is a normal magic square, a regular magic square, where from 1 to n square, just like it's a 4 by 4 magic square, you see 1 to n square, 1 to 4 square, that is 16, all the numbers are present, and they are arranged in such a manner that some of these numbers along the rows, along the columns, along the main and transverse diagonal are all equal to a certain number. That number is called the magic sum for that magic square. Like in this particular arrangement, the magic sum is 34. You can just try to add the numbers you see in front of you along the rows or along the columns, and you will see that this is always 34. But it is not necessary that all the magic square has to have this kind of 1 to n square, all of them. They can be just other arbitrary numbers, just like the next one here. It's a 3 by 3 formation. It's not all the numbers from 1 to n square, some arbitrary numbers, as you can see. But this is still a magic square because here also the rows, the columns and the diagonals, the main diagonal and the transverse diagonal, all the sum is same. And in this case, the sum is 63. So that's the magic square formation, right? So what Ramanujan was telling about magic square, you see, I must tell another thing also. Please bear with me to check that in this upper formation, 4 by 4 formation, this number 34 is not coming out of only the row sum, column sum and the diagonal sum, but also it can be proved in general that whenever you have a 4 by 4 magic square, the sum of the numbers in the 4 corners, just like here, 1 plus 4 plus 16 plus 13, they will also be the magic sum. The sum in the center, 7, 6, 10, 11, it's always true. This is always true. It can be proved as a theorem. It's always the magic sum. The number on top, 2 middle numbers, 14, 15, and the numbers in the middle in the last row, 2 and 3. Some of these 4 numbers will also be magic sum. Some of these 2 side numbers, the 2 numbers in the middle of first column and the last column, 8, 12 and 5, 9, they are added to magic sum. So these are actually the 14 different ways as far as 4 cross 4 magic sum, magic square is concerned. There are 14 different ways in which this magic sum can be achieved. And this is a theorem. It can be proved in general. No myth, nothing, no mystery there. It can be proved as a theorem. Now let us see what Ramanujan did. And this is what I would like to tell you. Beware of internet. In internet, you will find this particular one that I would like to show you. Now. Just give me a few seconds. I would like to show you this one. Can you see this? This in the internet you will find as Ramanujan's magic square. Let me tell you that Ramanujan didn't invent this particular magic square, but you look at this magic square, these are 4 by 4 formation. As I have already told you, this magic square has a particular magic sum, and that magic sum is 139. So the 14 different ways that I have already pointed out, but you see what they are stating here. Look at the language they are writing in the side. They are trying to impress upon you that this is something very special. These are the ways you sum it up, and always it is 139. Then say it is also the 4 corners. As I have already told you, it is obvious. Always it will happen. And then these numbers, the blue ones, and the purple one, that is also theorem. It is always true, nothing to do with this particular one, nothing special. But then something special comes. Okay, this is also not special. This is also common for every 4x4 magic square, that these 4 numbers will be the magic sum. Now these are new. These are new. This is something new. That doesn't happen always. This is also new. These combinations are new. And now they say, look at the climax. This is how they present the truth to you. The date of birth of Srinivasa Ramanujan. And that is the myth being attached completely unnecessarily with this beautiful mathematics. That as if, because the first line is 22/12/1887, that happens to be the birthday of Ramanujan, they ask you to be a proud Indian and share this particular one, that this is happening because of this Ramanujan's birthday. But let me tell you that Ramanujan's birthday has got nothing to do in particular with this particular magic formation. Ramanujan was not so silly. He didn't have so much time to have a magic square invented with his own birthday. What he did was brilliant. He gave a general formulation for making magic squares, right from 3 to 3 up to 8 to 8, as you can see in front of you. And in this particular 4x4 formation, he has given a formula, given a typical way of arranging this number so that this magic sum can be achieved in 22 different ways rather than the 14 different ways which is regularly true. That's my point. That's what Ramanujan did. That if you follow his path, his way of making magic square, you will be able to make a magic square, maybe with your own birthday, so that there will be 22 different ways of reaching the magic sum rather than the usual 14 ways. And this is what Ramanujan did. As you can see here, this is what Ramanujan did. He says that if you take 2 sets of number ABCD and PQRS and arrange those numbers in this particular formation, that's what Ramanujan is. That's the mathematics behind. Arrange them in this particular formation, then there will be 22 different ways. There's nothing particular with this, 22/12/1887. That is just something that you cook up. You can cook up your own date of birth. And that is not one single way. Ramanujan gave 2 different ways. One is this, the other is this one. And here you have, in the second case, there was a particular restriction that in this formation, your A plus D should be equal to B plus C and P plus S should be equal to Q plus R. Whereas in the first possible formation, there is no restriction whatsoever. Only ABCD, 4 positive integers, and PQRS, another 4 positive integers. And then you arrange them in this way, you will have a 4x4 magic square that will have all those 22 different ways of magic sum. This is my magic square, my friends. I have just followed Ramanujan's path and made my magic square. That's my date of birth, as you can see in red, 25/11/1966, and I am no Ramanujan. So that's my point, No point in making a myth out of everything. Look at the mathematics he talked about. That's the easiest mathematics that you can find out in Ramanujan's notebook. But my friends, does it mean that Ramanujan became so famous for this kind of magic square? Oh my God, never, never, never. This is something, child's play. Look at this gentleman. His name is Professor Bruce Bond of University of Illinois. Now this gentleman is a leading Ramanujan scholar. He spent 50 years of his life in deciphering, trying to prove the Ramanujan's result. In these notebooks, there are about 4,000 theorems. Somebody was telling at the beginning that 600 is something different. That I'll come to later. The original notebooks that I have shown you, there are about 4,000 theorems written there. And all these theorems, one after another, has been proved by this gentleman, Professor Bruce Bond. And it took him 5 volumes of books from Springer Verlag. 5 volumes. And as you can see, the name of this book and the year of publication. It ended only in 1998. Ramanujan's notebooks. Okay, coming back to Ramanujan's life. In 1909, when Ramanujan has established himself as a complete failure in the formal education, he was just wasting time as far as his parents are considered. His neighbors are considered that he's not even trying for any job. It's such a poor family. He's not trying to stand by his father. He's doing all sorts of nonsense. Nobody understands what he is doing, sort of mumbo jumbo. There's no purpose. His mother tried to bring him down to the track of normal life. And she decided that the best way of doing that is to get Ramanujan married. So she never bothered to discuss anybody, not even Ramanujan's father. Decided, found this particular family and get Ramanujan married with Janki Ammal, who was only 9 years of age at that point of time. And as you can see, Ramanujan, born in 87, he is about 22 years old. And Janki was only 9. Now this Janki Ammal, she continued to live till 94 years. This the picture that I'm showing you to the right of it, it's when she was 87. And this is the time when, as you can see, it's 1987, that's a centenary of Ramanujan was being observed all over India. And that is why Government of India and other agencies were very keen in finding out somebody related to Ramanujan. And then they just somehow found this lady. So pathetic that after Ramanujan's untimely and sad demise, Ramanujan's family sort of disowned Janki. Ramanujan's mother thought that it is due to something wrong in Janki's horoscope that brought this misfortune in Ramanujan's life. That was her belief. And as I told you, she was a very dominant kind of lady. And it happened after Ramanujan, his family never looked after Janki. Janki was simply thrown out of the family. She sustained by, learning to sew. She just managed to have a sewing machine out of ₹20 per month scholarship that he got from Madras University against the papers of Ramanujan. She collected all the papers that Ramanujan left in his deathbed, loose sheets, 138 loose such pages with 600 odd theorems written over there. That's the number 600 related to. These loose pages she handed over to Madras University, against which, and the copyright of the Ramanujan's work, against which Madras University used to pay her ₹20 per month. And that's how she sustained. She actually took care of an orphan child, a boy, adopted him. His name was Narayan. Janki looked after him very well, educated him. The boy later on went on to become an officer in State Bank of India, had a family, and that gentleman and his family looked after Janki till her death. She died only in 1994 at the age of 94. You see, this is the truth of our great country. That even after Ramanujan, nobody bothered to see to the welfare of his wife. Anyway, these papers, these loose papers, traveled from, changed hand. Madras University sent them to Hardy after death of Ramanujan. Hardy, after working with them few months, then he submitted it to Rankin, and then it went to Watson. Watson worked with them. Then, unfortunately, Watson died. Everybody lost track of those papers. And then Whittaker found it from the Watson's possession, from Lady Watson's possession, and then somehow submitted it to the Wren Library of Cambridge, Trinity College, and everybody forgot. It was after 75 years of Ramanujan's death, that one professor, George Andrews of Pennsylvania, completely by chance got hold of these papers. These papers are now referred to as the Lost Notebook. This is not a notebook. These are actually 138 pages of handwritten mathematics by Ramanujan in his deathbed. He did mathematics even 4 days before dying. Anyway, coming back to his initial life in 1910, these are a certain person who tried to stand by Ramanujan, at least some sort of patronizing, having a pat on his shoulder, if not something materially meaningful. They actually somehow made Ramanujan's life bearable. And this one gentleman, Diwan Bahadur Ramchandra Rao, he was also one of the founders of Indian Mathematical Society. The other one is this, Professor Ramswamy Iyer. This Ramchandra Rao from his own pocket, at a point of time, after again and again persuasion by Ramanujan and one of his friend, Radhakrishnan, this gentleman could see something of merit, possibly, of Ramanujan's easiest work, and from his own pocket gave ₹20 scholarship for Ramanujan. That actually allowed Ramanujan to sustain somehow. And it is due to this Ramchandra Rao's reference that Ramanujan got that Port Trust job. And this is the time, 1911, when the first publication of Ramanujan took place in the Journal of Indian Mathematical Society. That's on some properties of Bernoulli's number. And in the Madras Port Trust, the chairman, Sir Francis Spring, somehow took interest in Ramanujan's work. He was not a mathematician, he was an engineer, but somehow he got interested, thanks to another gentleman who was the immediate boss of Ramanujan, Narayan Iyer, who was a kind of, friend, philosopher and guide in Ramanujan's Port Trust days. They used to stay together. Narayan Iyer himself was a mathematics student. They used to do mathematics together in the night. And he actually motivated Ramanujan to write to the scholars and mathematicians abroad. He convinced Ramanujan that the Indian mathematicians and the European in India are not good enough to understand Ramanujan's mathematics. Ramanujan must try abroad. So that's how Ramanujan started writing letters abroad. And the first two letters went to these two gentlemen, Baker and Hobson, in Trinity College, both fellow of Royal Society by that time. And they simply didn't respond. They found it unworthy of responding. A Hindu Port Trust clerk claiming to have done something which are completely, bizarre, never seen such things in our life. This must be nonsense. So not worthy of spending time on there. So neither Baker nor Hobson responded. And if you remember these two names, within few more years, these gentlemen are going to sign on the recommendation of FRS for Srinivasa Ramanujan. That's life. But then came this great day of Ramanujan's life, 16th January 1913. The next letter went to Professor G.H. Hardy. A 10-page long letter packed with 120 formulae. Unfortunately, 2 of the pages are already lost, completely lost. Page number 8 and page number 10 are not found. And this gentleman got this letter on 16th January. And this is the beginning of the letter. Dear sir, I beg to introduce myself to you as a clerk in the accounts department of Port Trust office at Madras on a salary of only £20 per annum. I am now about 23 years of age. I have had no university education, but I have undergone the ordinary school course. After leaving school, I have been employing the spare time at my disposal to work at mathematics. I have not trodden through the conventional regular course, which is followed in a university course, but I am striking out a new path for myself. Look at the confidence. Look at the confidence of the language. I am striking out a new path for myself. While he was standing all alone on one side of the world, everybody against him, everybody thinking that he was doing nonsense. He was a madman, he was a cheat. And look at the confidence of this person. And he writes to Hardy, I have made a special investigation of divergent series in general, and the results I get are termed by local mathematicians as startling. And then there is a list of such formulae. These are 2 pages, page number 5 and 6 for you, my friends. One after another, such formulae. I just blow up one of them for you here. Enlarge them. Gamma functions, indefinite integrals, series for pi, and what not. This kind of things, this kind of formulae. Look at the number 2. This U is actually the thing we started with today. It's in that class. It's a continued fraction. Ramanujan was a master of continued fraction. And Ramanujan claims that if U is a continued fraction of this form and V is the continued fraction of that, then this is the relationship. This is the relationship between U and V. Later on, these are going to be the kind of now known as Roger Ramanujan identities. You see, Hardy later said that this formula defeated me completely. I have never seen anything like this before. Hardy, a Sadlerian professor at Trinity College, Cambridge, a fellow of Royal Society. And also, this kind of formulae, the one I have boxed at the end, it has become a myth with Ramanujan's name. Ramanujan proposes that the sum of all the positive integers, 1 plus 2 plus 3 plus 4, and then the ellipsis, dot, dot, dot. It means it goes on forever. All the positive integers are summed, then the summation will be minus 1 upon 12. See, my friends, if someone comes to you with such a result, you just can't, you just can't accept this blindly, and you must sympathetically look at those people who saw these results of Ramanujan in India and thought him to be nuts. If somebody comes with this kind of result to you, won't you also say that it's absolutely ridiculous? Positive integers being added to a fraction, and that to a negative number? It's a madman's job. And not only that, there are few equations. This is one I have just written over here. In Hardy's letter, there are 4 such equations. The very next one was 1 cube plus 2 cube plus 3 cube plus 4 cube, and dot, dot, dot is 1 by 120. You see? This is the kind of result Ramanujan writes. And what happened then? Well, even Hardy, at the first sight of these results, thought it to be nonsense. And he also, set this letter aside or threw it in the waste paper bin and went on carrying his regular routine. And then went to the department, took his regular classes, and then went to play tennis in the afternoon. But somehow, the whole day, this formulae that he saw one such, glance in the morning, this formulae was sort of pinching him. He was just trying to make out, what if these formulae are true? Is it possible for someone to just concoct so beautiful, so nice, so symmetric formulae which are meaningless? G.H. Hardy, have never seen such thing anywhere in mathematics. Is it a work of a genius? Or is it just a practical joke by some of my friends sitting in Madras trying to see whether Hardy can actually recognize me? What is it? Well, that particular day, the story goes that he left his tennis early, came back to his room, found out that letter from the waste paper bin, sprayed all these 10 pages on his table, and tried to decipher again and again. By the time of dinner, Hardy decided that this is not to be done by me alone. I must consult someone else. So he summoned his friend and co-worker, John Edensor Littlewood. And they together sat after having dinner the whole night with these 10 pages. And as the sun was dawning, they have decided in favor of Ramanujan that this must be the work of a genius. And such a person, if he is really what he claims himself to be, then this must be nurtured. He must be brought to England. And we must work together. We must collaborate. We cannot allow him to spoil, leaving him in India, in Madras, in one corner. And then Hardy responded to his letter. See, this particular equation, I'm afraid I don't have time, or perhaps this is not the right forum to explain the meaning, the significance of this equation. But let me take this much liberty and a bit risk as well, telling you, because this is a physicist forum, that while this equation have tremendous mathematical significance, is related with Riemann zeta function, related with Euler-Maclaurin series summation, it is amazing to know that modern physics, string theory, have seen this equation. I have seen this equation in the book by Polchinski, the book on string theory, explaining Casimir effect in quantum electrodynamics. The charge of vacuum between two plates, something like it's completely beyond my understanding. I know nothing about this subject, but I was amazed to see that even in physics, such an unusual equation pops up. That's what is the legacy of Ramanujan, my friend. What he told initially many of those results were thought to be partially true, not true, meaningless, maybe already known. But as time went on, 10, 20, 30, 40, 50 years, they came back, they bounced back and popped up from this or that corner with a complete new significance and mesmerized the world. That's the legacy of Ramanujan. So if you are interested in knowing the mathematics of this equation, I can just refer you to this lecture of mine, which I gave in 20th July in my college. If you go to the website, college website, and search the YouTube link, you will see a 1.5 hour lecture, particularly on explaining the significance of this equation from different perspectives. So leaving it aside, I just quote Hardy, what was his idea from the letter. He concluded, a single look at them is enough to show that they could be written down by a mathematician of the highest class. And then Hardy invited Ramanujan. Ramanujan got a letter from Hardy, an invitation. And then it was not so easy. There were socio-religious strictures. He was a pious Brahmin. Crossing sea was beyond question. His mother was never ready, neither he was. And then one good thing happened with the letter of Hardy. The Madras University now granted him ₹75 per month scholarship so that he could leave the job and do mathematics all by himself. Then came this letter of Hardy where Hardy asked for proof. Hardy told him that, okay, my friend, I am mesmerized. I am very impressed with your results. But you didn't prove one of them. I need proof. Modern mathematics does not accept anything without proof. So please give me the proof of your result. And this is in answer what Ramanujan is writing to him. 27th February 1913. Ramanujan writes, and I have underlined that read myself just to make you see what he is telling Hardy. He is telling, okay, this letter from you will at least save me from starvation. At least people around me will now think that I am not a madman. That G.H. Hardy told that my results are good. But Hardy, you want proof? What exactly is a proof? See, I do it in my own way. And in a letter, I cannot explain you my own ways of doing mathematics. If I try that, just like I did earlier to that gentleman Hill in London, you will also tell me. Now you look at this letter. This is the number. This is the equation. Can you see that? 1 + 2 + 3 + 4. He is again referring to this equation. And the language right after that is, under my theory, I got this. And then if I tell you this, you will at once point out to me the lunatic asylum as my goal. So even Ramanujan was aware of how unusual his results are in the context of ordinary mathematics. So he is telling that if I try to prove it in this letter, you will think that my actual goal is lunatic asylum. So please don't ask for proof. I can't do it in the letter. Rather, what he is suggesting to Hardy, he is suggesting that why don't you prove the result in your own way, the way you do mathematics. Only one request. If you can prove my results to be true, give the credit to me. Tell everybody that this is my result. I want to publish them. And being poor and inexperienced, I don't know how to do it. And this, coming and going of letter, it continued for almost a year because Ramanujan could not make his mind whether to go or not to go because of that socio-religious stricture of crossing the sea for a Brahmin. And in the meantime, what Hardy did is to organize this particular gentleman, E.H. Neville. He arranged for 6 months lecture at Madras University on differential geometry to be given by Neville. And he sent Neville to Madras with this particular, actually Neville was sent to convince Ramanujan. Apart from giving the formal lecture, his actual assignment was to meet and convince Ramanujan so that he may go and meet Hardy there and they may work together. So after persistent effort for 1 year, 17th March 1914, ultimately Ramanujan declared that he had a vision of Lord Namagiri. And immediately after that, his mother also declared to her society that she also had a kind of vision that some European gentlemen are, sitting around Ramanujan. And that must be some sort of signal from the Lord Namagiri that he may be allowed to go to England. So after all this kind of, this kind of mambo jumbo, Ramanujan was ready to leave. And he reached England in 14th April 1914, and this unusual and extraordinary collaboration began. But before leaving, Ramanujan gave his word to his mother that he will maintain the Brahminic way of living. And that's how he continued to have vegetarian food. Initially, that was no problem, vegetarian foods and fruits and milk. But the time was very unfortunate. Within few more months, First World War broke. And the whole supply of fruits and milks, particularly milk and milk products that used to come to London on the sea route, through sea route from Denmark, that was choked due to German U-boats. And there was a great lack of supply. And that took a toll on Ramanujan's health. At that point of time, we have letters written by Ramanujan to his friend in India that don't worry about me. Now I have learned how to live by eating rice with only lemon juice. Imagine a person traveling from India to this hot, temperate climate, who never have seen less than 35, 40 degree temperature in his life, is now shifted to London in sub-zero temperature, where you need good proteins to survive. And here you have a gentleman. He is not being able to have his own vegetarian food. And he is writing that I know how to survive on lemon juice and salt lemon juice and rice only. So it happened what was due to happen. And all this story, this extraordinary story, you can find in this fantastic book, the great biography of Ramanujan by Robert Canigal, The Man Who Knew Infinity. And there already is a Hollywood movie, 2015 on it. I'm sure most of you have seen that. And there is a Rupa book. And I'd just like to draw your attention to this fact that 125 birth anniversary of Srinivasa Ramanujan in 212, the then government of India has taken one particular initiative, apart from many other mathematical initiatives, to get this particular book translated in 10 regional Indian language. And it was a great fortune of me that I was entrusted with this Bengali translation, which I did eventually. And this is the Bengali translation, Antohine and Antojami, from MBT and Ramanujan Mathematical Society. And it's one of the greatest day of my life that this book was published by another great son of our soil, another fellow of Trinity, master of Trinity, Bharat Ratna, the Nobel laureate, as you can see, Professor Amartya Sen, in presence of another fellow of Royal Society, Professor M.S. Raghunathan, in a program made by Indian Statistical Institute on 19th July 2013. And I would like to share with you this happy news. The book has already been quite popular. It's a very satisfying experience for me that in West Bengal and Assam, it has been sold or ordered over 50,000 copies by now. Anyway, coming to Ramanujan's life, by 1916, he was publishing one of the fantastic paper at that point of time was the approximate number of prime factors of large integers. Integers can be broken into prime numbers always. That's a fundamental theorem. Ramanujan thought of finding out the number of prime factors for the arbitrarily large positive integer. And that's one of the smallest paper that was published in London Mathematical Society, that it should be in the order of log n. That's a fantastic paper. And then the fateful year 1917, when Ramanujan fell ill. He was again and again hospitalized in one or the other nursing homes, and there was contradicting detection by doctors. He was having severe pain in stomach and intermittent fever, high fever. Nobody could actually find what exactly was the problem. There were somebody telling that it was a blood poison, somebody told that this is a kind of cancer, somebody told that this is incurable tuberculosis. And finally, it was decided in favor of the then incurable white plague, which is tuberculosis. And this is right at that time. Ramanujan was in the middle of one of the most brilliant, one of the most fruitful collaboration with G.H. Hardy, working on the partition function. Partition of a number, as you know, is the number of ways a positive integer can be expressed as a sum of itself or the smaller numbers. Like 1 can be expressed in only one way, that is 1. But 2 can be expressed in 2 ways. Either it is 2 itself or it is 1 plus 1. So partition number of 2 is 2. In that way, partition number of 5 is 7. As you can see in this slide of mine, that 5 can be written in 7 different ways. And this is an unordered partition, in the sense 1 plus 4 is not to be distinguished from 4 plus 1. So this is the way number of partition is. So what Ramanujan was after, he was trying to find out the number of partition of any arbitrarily large integer. And you see this partition number, this function, this kind of functions are called arithmetic functions. It has, for every positive integer, there is a value of this function, like P10 is 42, P25 is 1958. And you believe it or not, P70, the number 70, the way it can be written as a sum of smaller numbers, it is larger than 40 lakhs. So it grows exponentially, very fast. And this is what Ramanujan conjectured. As I told you already, he had an uncanny ability of conjecturing formulae. Ramanujan conjectured that this number will be asymptotically equal to this expression, as you can see, 1 by 4n root 3 e to the power pi into root over 2n by 3. God only knows how could he guess such things, root over 2n by 3 as an exponent. But then Hardy and Ramanujan tried to prove this, and they could prove it by a great circle method, the method that allows you to sort of bypass the on the complex plane, you bypass the singularities by this beautiful method known as circle method. And this formula turned out to be brilliant, in the sense that this is an asymptotic formula, but if n is very large, then if you calculate Pn by this formula and take the integral part of the outcome, just ignore the decimal part, you get the exact answer. So that is one of the fantastic, most celebrated theorems of Ramanujan and Hardy, and that was done in 1917, when Ramanujan was already seriously ill, and was frustrated. Early in January 18, this is not much known, but out of frustration of possible depression. So depression was manifold. One depression was Trinity turned down his name from fellowship. Other depression due to loneliness in a foreign land. That's very unfortunate that his personal life was completely jeopardized. He was of the idea that Janki has forgotten me. She has never written a letter in these 5 years. While Janki, sitting in India, was thinking that Ramanujan has forgotten me. He had never answered any of my letters. And what happened in between? It was the mother, the Komalatammal. Janki has written several letters to Ramanujan in these 5 years. Every time Komalatammal confiscated those letters, told Janki that yes, I have arranged to send it to Ramanujan, but never send it. Actually put them in one box in his house, with the idea, perhaps, that these letters, if it reaches Ramanujan, it will distract him from his mathematical persuasion. So Ramanujan was felt absolutely lonely, depressed, and it is a fact that he attempted suicide in London Underground Rail. Thanks to the driver, that he could see Ramanujan early and put the brake in right time. But Ramanujan was taken into custody by Scotland Yard. As you know, that trying to commit suicide is an offense in British law. And it is now known that Hardy himself went there to bail out Ramanujan, and that too by a false statement, telling the Scotland Yard that you cannot just take into custody IFRS. As a fellow of Royal Society, you can do it like that. But Hardy was completely aware of the fact that Ramanujan was not an IFRS at that point of time. It's history. And then within few days or within 1 more month, Ramanujan really actually became FRS. And then, as I have already pointed out, he became a fellow of Trinity College as well. And then in 1 more year, in the March 1919, at the end of First World War, it was decided that Ramanujan will come back. He is already very, very ill. He came back to India. 27th March, he reached Bombay, and then 2nd April, he reached Kumbakonam, and he summoned Janki. Janki was not there with his family. She was immediately sent back to his father's, to her father's house. But Ramanujan summoned him, and this last year of his life, they stayed together. And it is that time when this husband and wife, they had chat among themselves. They came to know about this, this mental gap that was created by the mother. Anyway, what happened? To cut a long story short, This is the final letter that Ramanujan wrote to Hardy, 12th January 1920. See, it is just 4 months left. 4 months left before Ramanujan will leave us forever. And on 12th January, he is writing to Hardy this letter. As you can see, I have boxed that particular word, mock theta function. He is writing that, Hardy, you people work with theta function, but that theta function has certain singularities. It's not that good. I have designed one new kind of function, just distorting it a little bit, and I call it mock theta function. They behave in much better manner. And I'm giving you 22 such examples of this in that letter. He has given 22 mock theta functions in that example. That's the last letter of Ramanujan written to Hardy. And it is said, my friends, that these mock theta functions are so brilliant, so exceptional, perhaps the greatest stroke of his genius. And it is said that even if in his whole mathematical life he had done nothing else apart from conjuring these mock theta functions, he would have been an equally famous mathematician that he is now. Let me share with you this fact that in last 100 years of mathematical development, international mathematical development, no important result, internationally important result of mathematics that was discovered, that was invented, is not somehow or other related with the mathematics of mock theta function and the mock modular forms that emerged out of it, and the relevant theory of L functions and many others. Ramanujan relentlessly worked on them on next 4 months, and that actually made those 138 pages of loose sheets. These are the pages of that letter to Hardy on mock theta function. And you know, 26th April 1920, Ramanujan died. In the notebook, he has about 3,542 theorems. As I told you, every single theorem has been proved by Bruce Bernd. And then, 50 years down the line, in 1974, the Belgian mathematician Pierre Deligne, he got Fields Medal by proving tau conjecture posed by Ramanujan again, without proof. Look at that conjecture. It is in the logo of this ICM, International Congress of Mathematicians. You know, it was held in Hyderabad this 2010. I was fortunate to be there as a part of the Indian delegation. And this was one of the formal posters. You see, this is the Ramanujan tau function. Ramanujan gave this bound again without proof. And again, you see that uncanny ability that he told that it will be less equals to n to the power 11 by 2 into another arithmetic function, dn, divisors of n. And how come he could guess this 11 by 2? It's really mystery. But this exact result has been proved in the course of proving some other conjecture, of course, by Pierre Deligne. And he was lauded with the highest international accolade of mathematics, that's known as Fields Medal, in 1978. That's Ramanujan's tau conjecture for you. And this is the gentleman George Andrews that I have already pointed out in 1976 in a completely chance visit to Wren Library. He came across those 138 pages and those 600 new formulae written all over those 138 pages by Ramanujan's own handwriting. That is now referred to as Lost Notebook. And then George Andrews, along with Bruce Bernd, again worked on deciphering them, writing one after another 5 volumes of books. Those 5 volumes I have already mentioned are from Ramanujan's notebook. And these 600 formulae, they gave birth to another 5 volumes. And you will be surprised to know the last volume has been published only in 2018. So you see the relevance of Ramanujan's mathematics even in 2020. His work is now still being done, understood, deciphered, and rewritten. And connections from various different branches pop up from here and there. So allow me to finish as we commemorate the death centenary of this self-taught legendary son of our soil, who has led the world of mathematics mesmerized with sheer awe for last 100 years by his typically original ways of doing mathematics, his mathematical thought process that has not yet been totally deciphered, and his tragic, untimely demise, like the hero of a Greek tragedy, when he was at the peak of his creative genius. Despite his irrecoverable illness, it leaves us with wonder what could have been his further mathematical achievements had the destiny granted him a longer life. Allow me to finish by quoting Robert Canigal from his book, the great biography, as I have already pointed out, The Man Who Knew Infinity. I quote, "What Ramanujan did will live forever. It will not, to be sure, live in the hearts of the masses of men, like the work of Gandhi, Shakespeare, or Bach. Still, his ideas and discoveries, percolating through those few minds tuned to them, will mingle with the intellectual energy of the cosmos, and thence into the deep, broad pool of human knowledge. Thank you for your patient hearing.
Thank you, Dr. Mukhopadhyay. I can see one question in the chat box.
Yep.
Anirban Roy has written, I was born on 12th October 2000. That means there will be...
You can't make a magic square if you are born on 2000 or even on 2001, because these conditions cannot be satisfied usually by positive integers. Because you see, Ramanujan, I know what is his question without going through the question. There are certain years, of course, Ramanujan never told that it's possible for all years, but of course, if you have to express this as a sum of two integers and those are positive integers, then that's a restriction, and surely you cannot make the sum of two positive integers to be 0 or to be 1. So those restrictions are there. Unfortunately, if you are born on that year, you will miss a Ramanujan like magic square for yourself, and I am fortunate to have one for myself. Yes.
Okay, sir. Another question from Gibbon Bormon. Is there any connection between Ramanujan's formula and black hole?
Yeah, I actually have read that there is. Black hole is something completely beyond my domain of understanding. You people will understand better, astrophysicists, but it has been mentioned surely in the literature that Ramanujan's formula in black holes, in blast furnaces, and as I have pointed out, one like in string theory, but there are people who tell that these are somewhat far-fetched. I am not the right person to comment on the weightage of that remark, but it is mentioned in the literature, of course, that there is something to do with black hole development. I am not actually technically aware of the details.
Okay. Anand Mishra has asked, where can I read Ramanujan's notes and papers?
Oh, you have one volume of a book of all Ramanujan papers together, put together, published by TIFR, by Yogananda and others, 4 editors. There is a volume this large. It's published by TIFR. All papers of Ramanujan, right from the beginning, that Bernoulli's number that he published in 1911 while he was in India, to the very last paper that was published after his death by Hardy. All those compilation is there, and if you want to read Ramanujan's own handwriting, those are not papers actually, but all those compilation of his work, as I have already pointed out, there are facsimile edition of Ramanujan's notebooks published by TIFR. So that's available in TIFR and in net as well. You can buy it from nets, both hardbound and soft copies, softbound copies. I have myself the 2 volumes of that book.
In the chat box, I found question from not a question, right, by Dibbo Shankar. What is the point of discussing the life, the genius, the brilliance of Ramanujan today? After all, we are not a genius like him. Does it need only brilliance like Ramanujan to make some mark in history of science?
No, you see, life of genius people are discussed again and again by ordinary people like us, so that we can find a motivation from him. It's not just for mathematics only. His peculiar confidence, self-confidence, that what he is doing is right. His completely unusual story of his life, his toil, his triumph. All these are motivating for everyone who is fighting in his or her life, facing some kind of challenge, facing some kind of atrocities, and trying to prove his or her own ability to the level, not necessarily of Ramanujan's, but to his or her own level. He's trying to establish himself or herself in the society around. Such lives are always, they are a kind of fountainhead of inspiration. I think that's the most important relevance of knowing and celebrating this kind of lives. As I told you already, Ramanujan's mathematics is so special, so very difficult, so very specialized and high standard that let me tell you that it is not even in the master's level of a standard university course it is taught. Only if you are a number theorist, only if you are learning that too, a specialized part that's called algebraic number theory, that you come to know about Ramanujan's mathematics. I mean, I can tell you this much, that really there are only few hundred people possibly across the globe who can claim honestly that I understand Ramanujan's mathematics per se. There's only few hundred of them, but others may be a part of that. And there are so many areas that Ramanujan's mathematics are now popping up from this corner or that corner, and people are working on them, trying to understand that part of Ramanujan's work. So it is really of high standard. It's trying to understand Ramanujan is not necessarily trying to understand his mathematics. That will be extremely difficult for a common person or layman. It is completely impossible. But what we can have from his life is that fountainhead of inspiration, to see that such a person never dies. Such a person, they continue to live through his work. So it should motivate us to do our own work in our own small way, that once we will not be here. Nobody will live forever, but to leave some kind of mark in my own little way. The inspiration I need to do this kind of work perhaps can be drawn from these great lives. That's what I understand as the relevance of Ramanujan these days.
And the last question from Paula. Institution versus mathematical rigor in general, do you tend to romanticize institution a bit too much and ignore the importance of rigor?
No, there should be a right balance. It is said, of course, Ramanujan's case was completely intuitionistic. Not everybody will be Ramanujan. And if you go by intuition and you are not a genius, then there will be pitfalls. You will be ending up with, meaningless kind of things. So intuition is absolutely important, but intuition is something that is not known. How one can be intuitive, how to make someone intuitive. You cannot teach someone to be intuitive. Intuition is something which is genetic, which is really not understood clearly how it works. But intuition is important. Intuition is something as a kind of guiding factor, guiding force for the people who have intuition. But then, having things only intuitionally and leave it there is not good enough. Rigor comes next, that you need to check and establish for the general community, be it mathematical community, be it physicist community, that what your intuition tells is actually the truth, and there you require rigor, there you require proof. But you see, if you stop the flow of intuition in the name of rigor, then that is not the right thing to do. Intuition is the beginning. It is often said, I would like to take this opportunity to make this comment here. It's a very good question, that it is often said by historians who worked with Ramanujan's life and work that perhaps with all due respect and credit to Hardy, he was extremely a person of rigor-liking person. He was referred to as the purest of the pure mathematician, and it is said that perhaps at certain points, Ramanujan's unusual flight of intuition were bogged down somewhat by Hardy's demand for rigor. Perhaps instead of Hardy, if it was not the time of World War, perhaps if Ramanujan could meet the German school of mathematicians, people like Hecke and others, then perhaps his flight of intuition would given us more results. Because now it is known that what Ramanujan's intuitions gave us are almost all true and were proved by others later on. So if this flight of imaginations were allowed further by Hardy, without actually trying to prove them, getting them proved by Ramanujan himself, which in sense can be a waste of time for people like Ramanujan, rather than allowing him to consume more and more results that see, perhaps that would have been much better for the mathematics as a whole. But these are all, perhaps. Destiny had it this way. And we must give due credit to Hardy also. And as I told you, I end with that rigor and intuition, they should just walk hand in hand. Both are important, both are necessary in its own way. I see one more question here. Somebody is asking about Hardy Ramanujan number. May I answer it?
Yes, sir.
May I? Okay, actually, I didn't talk about Hardy Ramanujan number because it's so well known, because it's so common to everybody. That's why I didn't mention it. But since somebody is asking, Hardy Ramanujan number is also known as a taxi cab number. This is a particular number 1729. This is a number that was referred to Ramanujan by Hardy when Ramanujan was very ill in that 1917, that particular time. He was in Matlock House, and Hardy came from Putney to visit Ramanujan by a taxi cab. And when he entered Ramanujan's room, not knowing how to begin the discussion with Ramanujan, he just mentioned that okay, today I came by a taxi and the number seems to be rather dull. He mentioned that number, and immediately Ramanujan told that no, Hardy, it is not dull. This is the fantastic number. It is the smallest number that can be expressed as the sum of two cubes in two different ways. So that's how this number became famous, and it's called the taxi cab number. And immediately after that, Hardy was also surprised, extremely surprised. And then he asked Ramanujan that, okay, can you give me the number of the next stage? That is there such a number that you can give me, which is the smallest number that can be expressed in two different ways as the sum of fourth powers? And then Ramanujan tried a few minutes mentally, and then he said, no, Hardy, I can't give you the number. The number will be very large. And later, by using computer, those numbers were found, and it is really, really a very, very large number. So that's Hardy Ramanujan number.
We now have Professor Amitabh Datta, President of Former Students Association, with us. We would like to hear in short about Professor J.C. Bhattacharya from him.
First of all, can you hear me?
Sure, I can.
Yes, sir.
Okay. First of all, let me apologize for my late entrance. And let me also congratulate the speaker for his excellent talk. Now, let me begin with a book. We have expressed our regards for Professor J.C. Bhattacharya from our own platform. But let me tell you that he is a man who is actually regarded by a much larger national platform. There is a department called Vigyan Prasar, which is autonomous under the Department of Science and Technology, and they have published a book. Can you see this book? I believe if I hold it near me, it should be visible. Is it visible to the audience? Perhaps not. So let me just give you the name of the book. The book is Indian Scientists.
So that's from a little distance from the camera.
Sir, please slightly raise the book. Sir, আমি উপেন বলছি, আপনি বইটা একটু তুলুন, যতটা দেখিয়েছিলেন আরেকটু আরেকটু নামান বাঁদিকে উল্টো দিকে সরি উল্টো দিকে একটু নামিয়ে দিন হ্যাঁ ওকে স্যার ওকে
Okay, so this is a book, Indian Scientists, the Saga of Inspired Minds. This is published by Vigyan Prasar, a department under the Department of Science and Technology. This book has the names of some scientists who have really contributed to the development of science in India. The number should be something around 75-80. And of course, Ramanujan is there, of course, Meghnad Shah is there, and of course, C.V. Raman is there. But our esteemed Professor J.C. Bhattacharya's name is also there because of two reasons. One is his brilliant contributions to astrophysics. He was actually one of the pioneers of research in astrophysics in India. And secondly, because of his tremendous contribution in developing the Indian Institute of Astrophysics in Bangalore, he was associated with it in various capacities from 1982 to 2007. And that is a tremendous contribution. So I wouldn't take your time anymore because you have already went through a long and interesting seminar. So let me finish by saying that Professor J.C. Bhattacharya is really an extremely good choice by the Scottish Church College to have a memorial lecture named under him. It was very, very appropriate. Thank you very much.
Joyita Arup Rai here. May I be allowed to say something?
Yes, sir.
I must thank Professor Parthasarathi Mukhopadhyay. I was listening to you.
Mr. Rai, please turn on your camera.
Am I visible?
Yes, sir. Yes, sir.
Yes, okay.
Thank you, Professor Mukhopadhyay. This Jagadish Bhattacharya Memorial Lecture was introduced with the intention that we can listen to speakers on any subject under the sky. That was the very intention behind it. And today, what I find is the very intention has been vindicated because I could listen to a wonderful tribute to the intuitive genius of Ramanujan. Thank you again.
So, Joyita.
So it is the time to conclude now. I request Dr. Shudev Bhattacharya, Vice President of Former Students Association of Physics, to offer the vote of thanks.
Ushantoda, your microphone is off.
I kept it off deliberately.
না বলছি সুদেবদার কথা শোনা যাচ্ছে না। সুদেবদা কি জয়েন করেছেন?
Okay, let me call him and check.
জয়িতা?
ঠিক আছে আচ্ছা আচ্ছা Unfortunately, Professor Shudev Bhattacharya cannot reach the network. His line has gone bad. So let us continue without him.
না জয়িতা? জয়িতা? Hello.
So I request Dr. Joydeep Mitro to offer formal vote of thanks.
Fine.
So, am I audible?
Yes.
Yes.
Okay. So we have come to an end of an entertaining lecture. Thank you, Professor Mukhopadhyay, for this very enlightening and enriching lecture. And in this regard, I would like to thank our principal madam of the college, Orpita Mukherjee, vice principal Dr. Supratim Das, for giving us this opportunity and online platform to organize this lecture. I thank Professor Amitabh Datta, who is the president of Former Students Association, and Dr. Joyita Chaudhary, who is the secretary of our Former Students Association, also our head of the department, Dr. Upendranath Nondi, and other faculty members like Dr. Shatodal Bhattacharya, Rabindranath Shashmal, and Dr. Pradipta Kumar Mondol. Special thanks goes to our faculty, Sushobhan Pal of Physics Department, who provided this splendid technical support so that the program runs smoothly. And not only our faculty Sushobhan, there is also students like Krishanu Sengupta and Saurabh Das. They also provided help in streaming the YouTube channel or YouTube link. So at the end, I thank again Professor Mukhopadhyay that putting this beautiful lecture to us. So thank you all for patient hearing.
Thank you.
Yes, thank you. Okay, Joyita, we are leaving.
Thank you. Yes, sir. Thank you so much to everyone.
স্যার একটা কোশ্চেন ছিল স্যার।
অরূপদা শুনতে পাচ্ছেন?
স্যার একটা কোশ্চেন ছিল।
ওকে, কোশ্চেন করছে, সব বেরিয়ে গেছে। তুমি কে? হু আর ইউ?
আমি রাহুল বলছি।
রাহুল, তুমি স্যারের সঙ্গে পরে কথা বলে নিও, এখন
ঠিক আছে,
হয়ে যাওয়ার পরে। তো তুমি জেসি ম্যাডামের সঙ্গে একটু যোগাযোগ করবে, জেসি ম্যাডাম কানেকশন করে দেবেন। হ্যাঁ, তখন কথা বলবে। ঠিক আছে। আমাদের প্রফেসর সেন, অরূপদাকে দেখতে পাচ্ছি, অসীমকে দেখতে পাচ্ছি। হ্যাঁ, সবাইকে অসংখ্য ধন্যবাদ। আপনাদের এই যে আমাদের এক্স কথাটা বলবো না, যেভাবে সাপোর্টটা পেয়ে আসছি, সব সময় পাশে থাকছেন। কাশিদা, কমলদা, প্রশান্ত দাকেও মাঝে মাঝে পাই। আপনারা সবাই, বিভাস দাকে আমি দেখতে পেলাম না, চেহারাটা বোধহয় জয়েন করেছে। হ্যাঁ, সবাই আপনারা পাশে থাকবেন, আমরা যেন আপনাদের সাহায্য নিয়ে এগিয়ে যেতে পারি। থ্যাংক ইউ।
Thank you, Upen,
হ্যাঁ,
for organizing this.
না, জয়িতা অনেক পরিশ্রম করেছে, প্রচুর। সুশোভন আমাদের সব করছে এখন, আরো লাইনে আছে, আপনাদেরকে জানাবো সব সময় মতো। আচ্ছা, থ্যাংক ইউ। হ্যাঁ।